Welcome once again to our class on Riemann Sums. Today, we want to solve some examples. I want to look at how to estimate the area under the curve using examples. Examples on the estimation of area under the curve I take the first question. It says, estimate the area under f of x equals x squared on the interval 0 to 10 using midpoint Riemann sum for n equals 5. We want to estimate the area under the curve f of x equals x squared on the interval 0 to 10 using midpoint Riemann sum. Remember that the area under the curve A using Riemann sum is estimated as the summation from I equals 1 to n of f of xi delta xi. But in this case, our n is equal to 5. That means we are looking at 5 subintervals. 5 subintervals in the interval 0 to 10. How do we get the width of each of the subintervals? Remember that our interval 0 to 10 is equivalent to our interval AB. The width of each of the subintervals can then be what? B minus A over n. And that is 10 minus 0 over 5. That is 10 over 5, and that is 2. That means we want to have a subintervals of 2, 2. Let's look at it. Interval 0 to 10 equal subintervals having a width of 2, a width of 2, two, 2, and then 2. So those are our subintervals: 0 to 2, 2 to 4, 4 to 6, 6, 8, and 8, 10. But remember, we are told to use the midpoint Riemann sum. So we need to get the midpoint of these intervals as our tag. Tag or sample points equals the midpoint of the subintervals. The midpoint of the subintervals. And if it is the midpoint of the subintervals, no, I shouldn't have cleaned that. Area A, summation I from 1 to of that. Yes, our tag Ti now, the midpoint of the first subinterval 0 to 2 will be 1, 2 to 4, 3, 4 to 6, the midpoint is 5, 6 to 8, the midpoint is 7, 8 to 10, the midpoint is 9. Therefore, the area under the curve will be summation from I equals 1 to 5 of f of Ti delta x. Remember that we have gotten our delta x before because it is equal subintervals, and I don't need to use delta xi, but I use delta x, and this gives me what? Delta x into the summation from I equals 1 to 5 of f of ti. We got our delta x before as what? As 2 into f of 1 plus f of 2, f of 3 rather, plus f of 5 plus f of 7 plus f of 9. And that gives us 2 f of 1. Remember our f of x is 1 squared. This gives us 1 raised to power 2 plus 3 to power 2 plus 5 to 2 plus 7 to power 2 plus 9 to power 2. And that gives us 2 into 1 plus 9 plus 25 plus 49 plus 81. By the time we solve that all, we arrive at the area under the curve. 1 plus 9, that's 10. 10 plus 25, that's 35. 35, 49 plus 80, that's 130. 130 plus 35, that's 165. By the time we multiply that by 2, it gives us what? It gives us 330. That is the area under the curve. I'm going to leave us with an example which we are going to do, and then I see you in the next video. You can try your hand on this. Following the procedure, you can try your hand on this. Estimate the Riemann sum for f of x equals x squared on this interval using 4 subintervals of equal length where our xi is the right endpoint in the ith interval or the ith subinterval. So I will leave us with this question, and we can attempt it and see how far we can go using the formula for Riemann sum, or area under the curve using Riemann sum, and then we see what the answer will be. In the next video, we proceed from where we stopped today. See you!